Welcome everyone. Today we're going to talk about what are plate tectonics. So what are the plates that sit under our feet? Did you know that the Earth's crust is made up of a bunch of tectonic plates which are constantly shifting? Don't worry, each plate moves super slowly. Think a few millimeters to a few centimeters per year, depending on the place. How many tectonic plates are there? No one knows for sure, but most estimates fall in the range of 15 to 25, with a few big plates taking up most of the space. You may hear terms like the Eurasian plate, which takes up most of Europe and Asia, though pieces of other smaller plates underlie some of the outer parts of Asia. Tectonic plates can be made up of oceanic or continental crust. Some plates are made up of a bit of both. As you can probably guess, oceanic crust sits low underneath most of the oceans, while continental crust sits a little higher and parts of it reach the surface, allowing us to use land as what we call continents. This is because oceanic crust is denser, also known as heavier, than the continental crust. As a result, when two plates collide, one being oceanic crust and one continental crust, so the oceanic plate sinks beneath the continental crust. In comparison, when one continental plate crashes into another continental plate, they both go up and into each other, causing mountain ranges. Oftentimes, the crusts stay connected, leaving the exact point of differentiation between crusts and their underlying plates hard to determine. A second type of plate boundary is called strike slip. This is when two plates are sliding past each other, and they usually result in less extreme shaking events, but not always. The San Andreas fault, for example, is strike slip, and that fault has caused some major events in the past. Strike slip faults can be either left lateral or right lateral. The direction refers to which way the opposite plate is moving. For example, if you're standing on plate A and plate B appears to be moving left, then you're looking at a left lateral strike slip fault. The beauty of this naming convention is that it holds true regardless of which plate you're standing on. That means that if you were standing on plate B at a left lateral fault, then plate A would also appear to be moving left. On the other hand, if you're standing at a right lateral strike slip fault, the other plate will always look like it's moving to the right, regardless of which plate you're standing on. Generally, a piece of crust is considered its own plate if it still has its own range of motion. For example, the Australian India plate is still moving northward relative to the Eurasia plate, raising the heights of the Himalayas at a rapid pace of 5 millimeters per year, so we consider them as separate plates. When two plates are spread apart, usually where two plates connect in an ocean, this is called a ridge or a ridge line. As the plates pull apart, lava flows out from the mantle layer, which is the layer of earth beneath the crust. We can think of this like yolk flowing out of an egg wherever its shell is cracked. The lava flowing out from the mantle cools quickly and turns to rock, leaving young rock at the ridgelines and older rock which is moved further away from the ridgelines. We can see the process of lava flowing out of the ridgelines to make new young rocks actively happening at the mid-Atlantic ridge as one piece of evidence for plate tectonics. This is going to be the ridge line that sits in the middle of the Atlantic Ocean between North America and Europe, and also South America and Africa. We can add to this evidence by checking ages of the rocks near the surface and see those ages increase as we move further away from the ridgelines and we see the rocks get older and older. Are there some other pieces of evidence that we can use to look for plate tectonics? Yes. In the last section, we touched on mountain ranges and the ages of ocean floors. Some other evidence includes paleomagnetism, earthquakes, shapes of continents, and fossils. Why are fossils important here? Well, frequently we find that fossils of a species are similar ages and are found on the edges of two continents, but not anywhere else which currently connects the two continents. For example, fossils of the same species, which are the same age, can be found on eastern coasts of North and South America, in addition to the western coast of Africa. In other words, either the coasts would have had to have been connected during the time when the species was alive, or the coasts themselves were once touching each other and have now separated. This is not necessarily proof, but it is some evidence adding to plate tectonics. Furthermore, if we look closely at the edges of some continents with similar fossil records, we can see the possibility of continent shapes fitting well together. This is really clear if we look at the shapes of South America and Africa, for example. Look like they fit together really well. Plate tectonics is going to be what most of the time gives us earthquakes, mountains, and volcanoes. Mountains create the way that I mentioned earlier, where two continental plates crashing into each other causes the crusts to push together and go up. Earthquake shaking occurs from a couple of different methods. One of them being when plates crash into each other or slide past each other, or one plate dips under another. Simply the crusts of the plates bumping together are going to be enough to cause earthquake shaking. Something related, which I think is really interesting, is how the most common volcanoes form due to plate tectonics. As oceanic crust is subducting under a continental plate, it drops further and further underneath the continental crust and into the earth. It gets hotter and it starts melting. Hot, melted rock and fluids from that oceanic crust then rise to the surface and shoots through the overlying continental crust as a volcano, spewing magma and melted rock everywhere. That's all I have for you today. Thank you all so much for listening. I hope you learned something good and enjoyed the episode. Take care.